Transports are designed and operated at a higher level of safety than other airplanes. If an engine fails during takeoff, a transport must be able to safely stop or continue the takeoff and enter a safe climb for a return to the airport. Since transports can carry a large payload and fuel for long flights, there can be a large variation in takeoff gross weight. The available runway can limit the allowable gross weight, which means that the airplane can need the entire runway length for a legal takeoff. Takeoff performance criteria, with an engine failure at the most critical time, are specified by regulation. Precise adherence to the criteria is necessary to deliver the required performance. The required takeoff performance for transport airplanes and most civilian jets is divided into three segments. The first segment includes the takeoff roll to V1, the decision speed, where an engine fails and the takeoff roll continues to the rotation speed, VR, where the airplane is rotated to the initial climb attitude that will maintain the takeoff safety speed, V2. After liftoff, the landing gear is retracted when a positive climb is established. The second segment climb is usually the most critical segment. It involves a steady engine-out climb at V2 from gear up to 400 feet. V2 is not the best angle of climb speed, which for most transports is usually about 50 knots faster than V2. The second segment climb requires a climb gradient of 2.4% for two-engine transports, which means an altitude gain of 2.4 feet for every 100 feet traveled. This equates to a climb angle of slightly less than 1.4 degrees. V2 is usually the minimum speed that will deliver this climb angle. Although a faster speed could be used, since moving closer to the best angle of climb speed will improve the climb angle, the result would be a longer ground roll. In order to minimize ground roll, a V2 is usually selected that will just make the 2.4% climb gradient. The third segment climb begins at 400 feet, where acceleration and flap retraction take place while climbing at a specified minimum climb gradient to an altitude of 1,500 feet. For two-engine transports, this climb gradient is 1.2%, which is a climb angle of slightly less than 0.7 degrees. The takeoff roll begins with all engines operating. If an engine fails before V1, a safe stop can be made. If an engine fails after V1, a safe stop cannot be made on the available runway, but an engine-out takeoff can be accomplished. At rotation speed, VR, a 3 degrees per second rotation rate to the initial climb attitude for the second segment climb will establish and maintain V2 after landing gear retraction until reaching 400 feet. The pitch attitude is then reduced, allowing airspeed to increase while flaps are retracted at their scheduled airspeeds, while maintaining the required minimum climb gradient. We will now look at a simulation that illustrates a jet transport takeoff climb profile with an engine failure at V1 for a typical twin-engine wide-body airliner. This demonstration shows a typical takeoff profile for a wide-body jet transport operating at sea level with a gross weight of 320,000 pounds. Flaps 20 is set for a minimum ground roll takeoff. For these specific conditions, the engine will fail at V1, the decision speed, which is 135 knots. Rotation occurs at a VR of 139 knots. Rotating to an initial climb pitch attitude of 9 degrees establishes the second segment climb at a V2 of 143 knots and a climb angle of 1.4 degrees, which meets the required climb gradient of 2.4% when the gear is raised after a positive climb is established. At 400 feet, pitch attitude is reduced slightly so that acceleration can occur while maintaining the required third segment flight path climb angle of 0.7 degrees. Maintaining this climb angle, flap retraction to flaps 5 occurs at 160 knots, flaps 1 at 168 knots, and flaps up at 204 knots, while power is reduced to max continuous and the climb is continued to 1,500 feet. We will now increase the simulation speed to observe the flap retractions. How the V speeds are determined and takeoffs with other flap settings are covered in following videos. This profile is used for determining whether aircraft performance meets FAA certification standards for transport airplanes. Other profiles are usually used in normal operations. Generally, with an engine out, a climb at V2 is used to clear nearby obstacles, followed by flap retraction during acceleration in level flight or a gentle climb. Practical all-engine and engine-out climbs are also shown in following videos.